A parametric curve is a curve defined by its y's and x's, which are any function g of t or any function f of t. These, the t can be anything between the constants a and b, which could be a whole range of numbers, any of those in between, and then it has a derivative at any point t naught where g of t and f of t also have a derivative. As shown in our previous definition, x equals f of t, or in this case we have replaced it with the function cosine of t, and y equals g of t, in this case we've replaced it with sine of t. Our range is from the constant 0 to 2 pi, and any number in between there that you plug in is differentiable in this function.
Okay, using the definition of parametric equations, you use dy dx is equal to dy over dy dt over dx dt. So using these equations, x equals 4 sine t and y equals 2 cosine t, you take the derivative of each function on its own, and then you plug in, then you do, so dy dx would be equal to negative 2 sine t because y is equal to 2 cosine t, and the derivative of 2 cosine t is equal to 2 sine t. And the derivative of dx dt is 4 cosine t because when you find the derivative of 4 sine t, it's 4 cosine t.
As previously explained, dy dx is equal to dy dt over dx dt, with x equaling this function and y equaling this function. If we try to find the second derivative of dy dx, then we get dy prime dt over dx dt. And to find dy dt, we do the quotient rule, where you take the bottom, you multiply it by the derivative of the top, and then subtract the top multiplied by the derivative of the bottom, all over the bottom squared, to get dy prime dt. Then you divide the whole thing by 4 cosine t, because that's dx dt, dx dt, dx dt. As shown before, this is your first step. You have this all over this. Then you go to simplify through here. You simplify farther, and you end up with 2 cosine squared t minus 2 sine squared t over 4 cosine squared t times 4 cosine t. If you look in the book, you'll find a different answer because we simplified in a different way. As you see, we have cosine squared and sine squared. To find the length of the curve, you set L equal to the integral from a to b of the square root of dx dt squared plus dy dt squared dt. If y equals 2 cosine t and x equals 4 sine t, and a equals 0 and b equals 2 pi, then L equals from 0 to 2 pi of the square root of 4 cosine t, as that is the derivative of x squared, plus negative 2 sine t squared, as that is the derivative of 2 cosine. To find the surface area of a function, you take the surface area equal to the integral from a to b of 2 pi y square root of dx dt squared plus dy dt squared dt. This is if you want to revolve it around the x-axis. If you wanted to revolve it around the y-axis, you would instead switch this out for x. If your function is defined as x equals 4 sine t and y equals 2 cosine t on the interval from 0 to 2 pi, then the surface area is equal to the integral from 0 to 2 pi, of 2 pi 2 cosine t, square root of 4 cosine t squared plus negative 2 sine t squared dt.